2021 Ichi-Nissan Chico Go-Ban, just an A-B question. Let's get to my blank screen. It's got 4 good parts. I've got that from the previous one. Okay, here we go. Part A. Oh, they just asked me to find a derivative. Okay, they have 2y squared minus 6 equals y sine of x. All right, so this is just right. This is just implicit differentiation. That's what they're testing us here. So we have 4y dy dx. Ooh, 6 goes away, sweet. That is a product rule, which is y times the derivative of sine x, which is cosine x, plus sine x times the derivative of y, which is dy dx. So remember, what we're going to do is we're going to get all of our dy dx's on one side. We're going to keep everything else on the other side. We're going to factor out my dy dx. Oh, you guys, I hope this was worth like 9 points. But let's be honest, it was worth probably at least 2 points. So you guys are doing awesome. There's just no way you are not doing awesome. All right, so that was part A. I think when I looked just really quickly, I think it said there were 4 parts. But if there were 4 parts, then there's no way that one could have been worth more than 2 points. Okay. All right. So let's go ahead and take a look at this bad boy. The next one says, oh, sweetie sweets. It's just the equation of a tangent line through 0 comma square root of 3. So we're just y minus y1 equals mx minus x1, right? And then they are, oh, come on, let's go. Couldn't get more okay, right? That's it. That's it. And then I just have to find m. Well, remember, m is the derivative, right, which we just found. But we just have to put a square root of 3. We just have to put a 0 in for x and a square root of 3 in for y. So it's going to be, if we remember, my dy dx, and you guys would obviously have it in your little booklets, right? You don't run out of room like I do here on the screen, but it's going to be the square root of 3 cosine of 0, which is going to be Ichiban, which is 1. On the bottom, I get 4 square root of 3, right, minus sine of 0, and sine of 0 is 0. So I just get 1/4, plug that guy in, get 2 more points. Let's go. For reals. And remember, if you made a mistake, well, they actually gave you the derivative, right? So they were actually helping you out. So they asked you to verify what it was equal to with the original problem. Okay, so even if you shouldn't have made a mistake with part A, but if you did make a mistake with part A, okay, now looking at C, I can see exactly why they gave you the derivative to start out. Okay, makes their AP graders not go crazy in case you made a mistake. Right? Now, what's the hope here? The hope here is they're just asking for what are the coordinates when you have a horizontal tangent, right? And we all know by now, we have a horizontal tangent whenever the derivative is equal to 0. The derivative would be equal to 0 whenever the numerator is equal to 0. Well, the numerator will be equal to 0 whenever y is equal to 0 or whenever cosine x would be equal to 0, right? And so all you got to think about right now, okay, very quickly is, and remember, the one thing you always want to be careful about is you can't get 0 over 0. Remember, 0 over 0 is bad. And the one thing that I notice immediately is that if I plug a 0 in for y into this, I get 0 over 0. Okay, so that means we're going to scratch out that, which means the only answer is this guy right here. Now, it says earlier that you're just from 0 to pi. So hopefully we all remember that at pi over 2, that's my answer. All right, but they do ask me to find the coordinates. So I'm sure everybody remembers at home. Whenever I want to find the coordinates, we plug our x value into the, say it, original, right? So we're going to plug that into the original, and we get 2 pi squared minus 6 equals y sine of pi over 2, which is Ichiban. So we get 2 pi squared minus y minus 6 is equal to 0. Oh, and they give me a nice and easy factoring problem, right? And then I get y equals negative 3/2. I get y equals 2. So I get 2 answers here. I get y equals negative 3/2. I get y equals 2. But looking at the problem here, it says y has to be greater than 0. So it throws that dude out. So your only coordinate where you have a horizontal tangent is that bad boy. Boom, boom. Not horrible, right, guys? There's just no way. My now D's got to be a rough one, right? I mean, each one of these were probably worth a couple of points. There's one of these that would have been worth 3. Gosh, if I had to pick one that had to be worth 3, and I haven't done part D yet, but I thought that last one was pretty darn involved. But let's see. Maybe the next one's even a little bit tougher. All right, so it says determine whether F has a relative min, max, or neither at the point found. Okay, all right, so this one here could be a little bit tougher. Now, the point found in the step before, I'm going to write that down, was pi over 2. So this is one where you could have maybe made a mistake here, right? And if you made a mistake here, you could still do the problem, and I hope you guys at least answered it. Now, remember, we've done a lot of things in class that if I want to know if this is a min or max, and remember, that's a critical point because if I were to plug those values, right, into the derivative, I would get 0. Now remember, we've done a lot of these. If I were just to find, and boy, would it be a doozy in this one, but if I were to find the second derivative, right, if it's positive, it's going to be concave up. If it's negative, it's going to be concave down. It would help me to determine if it was min, max, or neither. And it would be neither, obviously, if the second derivative was equal to 0. Well, you know what? I think this is probably what I would do. I think it would be even though it's going to be some work, it would probably be the easiest thing to do because then it's just a plug and chug at the very end to get an answer. So let's go ahead and do it. Okay, maybe they wanted you to do it for sure and they were going to give you a point for doing the quotient rule. And the quotient rule is the low, okay, times the derivative of the high. And the derivative of the high we already did, but remember it is a product. It is a product rule. Okay, plus cosine x times dy dx, which is just going to be 0, right? We just found right there. So that's not too bad. So I did that times that, and then it's plus the high times the derivative of the low, which would be 4 dy dx, and then minus cosine x. Okay, all over low. So you guys, I mean, that wasn't horrendous, right? And then you're just going to plug and chug. You're going to put all of these values, the pi over 2 and the 2, in for all of those. So if we do that, what do we get? 8 minus 1. That's what I get from the beginning part, right, you guys? And then for the y here, I get a 2, and then it would be a positive 1, right? Because it'd be negative 1, I'm sorry. Negative 1 in there. Plus, that's just going to 0. Okay, that next one, plus, let's go ahead and see. Oh, look at this. You guys, this whole thing is going to be 0 because that's 0 and cosine of pi over 2 is 0. So that whole thing zeros. And then it's going to be all over. And I know this is really sloppy, but it's not too bad. So you get that. So I just get 7 times negative 1, negative 14 over 49, which is less than 0, which means it is going to be, whoops, no, I'm not doing an overestimate. Look at that. It's going to be a maximum because the second derivative is positive. Okay, not that now doing it, every problem was probably worth 2. That one was probably worth 3. Okay, all right, here we go. Let's get done with this last one. I'm hoping to have enough time to get it done before you guys walk in here on an Aloha Fridays. All right, here we go. Boom. All right, see you soon.